Hey everybody, welcome back to 5-Step Method, part 2. So we're going to review what you guys were learning in 5-Step Method yesterday. This one's a little tricky, it takes a bit of practice, but once you get good at 5-Step Method, you can solve lots of redox questions. So this is a reaction that I always do at school, a demonstration that I do outside. So I'm going to have to show you videos instead for that, but we have, and by the way, we're in your study guide, page 204, if you're following along in your notes. So this is a very simple one. We have water and sodium metal. Those are the only two reactants. That's it. So using 5-step method, you have to decide, are those oxidizing agents or reducing agents? What's going on? So I have our data book, and in your data book, you will need to be open to page 7. So I'm going to start looking these guys up. So I said sodium and water. Okay, well, here's water. It's a very weak reducing agent. Remember that these are the weakest reducing agents, and they get stronger as you go down. And this is the strongest oxidizing agent, and it gets weaker as you go down. Okay, so water is a pretty weak reducing agent, but it could still react. So we're also looking for sodium and metals. If you look, you'll notice there's lots of metals on this side as reducing agents, and as you go down, they're getting stronger. So sodium metal, I'm almost at the bottom. There it is. Okay, so that is definitely going to be the strongest reducing agent in this reaction. Now I had water as a reducing agent, but remember water also is an oxidizing agent. Now it's not strong, but in fact it's fairly weak, but it is strong enough to be spontaneous. So the oxidizing agent, remember the spontaneity rule, the oxidizing agent sits above the reducing agent. So water can react with sodium metal. So those are our two half reactions that we need. Excuse me. So using 5-step method, we've figured out our oxidizing agent, our reducing agent. We know it's spontaneous, and now we can take those half reactions and come up with the net. So water, 2 electrons, and that was our oxidizing agent. Water plus 2 electrons gives us 2 hydroxides and hydrogen gas. And our strongest reducing agent, we decided, was sodium metal, which is very strong. And it loses 1 electron to become Na+. So all entities present, I kind of forgot to do that, but all we had was water and sodium. That's it. Okay, combine the reactions. Now remember, every redox reaction, electrons gained have to equal electrons lost. So we have 2 gained, 1 lost, so we need to multiply everything in the bottom by 2 to get our electrons to balance. 2 sodium, 2 electron, 2 sodium ions. Okay, 2 gained, 2 lost, they cancel out. Now we've balanced our electrons, we can add everything else up. H2O plus 2 sodium gives 2 hydroxides plus hydrogen gas plus 2 sodium ions. Okay, there's our balanced redox reaction. And is it spontaneous? Yes, we already looked. The oxidizing agent is above the reducing agent. Diagnostic tests. What could we do to verify that this reaction actually works? Well, we have hydrogen gas. If you remember, we can do a pop test. Hydrogen gas is explosive. So there's my boom. So we can light it on fire and see if it blows up. We're going to try that right now. So I have a video of sodium and metal being added to water. So the fizzing is the gas bubbles. It's exothermic. It generates enough heat that it can ignite the hydrogen gas. Okay, so you saw that we do have hydrogen gas being produced. It popped or caught on fire. Now, is there anything else we could do a diagnostic test for? Sodium ions are they're colorless in water. You could do a flame test on those, and you could look it up in your data book for the flame test. And if I did that, sodium ions, do we even have them in there? Flame test is, no, I don't see it. Okay, scrap that. And let's go with hydroxide ions. So what do you guys know about hydroxide ions? Okay, hydroxide ions are always basic. They're the component of a strong base. So how can we test to see if we're making a strong base? We could use an acid-base indicator. So I'm going to go back to your data book, and there is a table of acid-base indicators in here. And so the one I'm going to use is phenolphthalein, and we're on page 10 of your data book. So phenolphthalein. Phenolphthalein is colorless when the pH is less than 8.2, and then it switches to pink at a pH greater than 10. So if we can get a pH greater than 10, it should be pink. And if you think about it, hydroxide is a strong base. So a strong base should definitely bring the pH above 10. So now we're going to do the same reaction, except this time we're going to put it into water with some phenolphthalein. And the phenolphthalein is already in here because it's colorless. So colorless phenolphthalein means its pH is less than 8.2. We'll add the sodium metal. And it's pretty obvious that phenolphthalein is turning pink, which means that solution has a pH greater than 10 due to the hydroxide ions. Okay, so we have a positive diagnostic test for strong base, OH minus, phenolphthalein turns pink, and hydrogen gas, pop test, or explosive. We saw that as well. So we have two good diagnostic tests to verify that one works as predicted using the 5-step method. Okay, moving on. So disproportionation is the topic of the day. And in your notes, you need to fill in that definition. So if you want to pause it and write down, disproportionation is any reaction where a species is both oxidized and reduced. In other words, one substance is the oxidizing agent and the reducing agent. So we're going to look at Fe2+. And if you remember, or maybe you didn't remember, but on your table of relative strengths, if we look at iron 2+, you will discover that it is an oxidizing agent and there we go, a reducing agent. Okay, so it is both oxidizing agent and reducing agent, which means it's capable of gaining and losing electrons. So what would happen if Fe2+ both gained and lost? So we're going to write out the two half reactions that we just wrote down. Fe2+ can gain 2 electrons as an oxidizing agent and become Fe solid. Okay, in this case they say liquid, but it doesn't matter. I'm going to change that to a solid. Fe2+ can also lose 1 electron as a reducing agent and become Fe3+. Okay, if I want the net reaction, then I need to times the bottom one by 2 so that I can get 2 electrons. Okay, 2 electrons gained, 2 electrons lost. Those are balanced. Our net reaction is 1 Fe2+ and 2 more is 3 Fe2+. Collide together to give us an Fe solid and 2 Fe3+. So that's disproportionation. You have one reactant as both oxidizing agent and reducing agent. Okay, diagnostic test for this. Is it spontaneous? Can we do a diagnostic test? Okay, so this one is not spontaneous, okay? It needs some help. It will not happen on its own. So that might mean an incredible amount of energy or multi-step reaction, something to get it to go. So wouldn't happen on its own. If we could get it to go, what would it look like? What would be some diagnostic tests for this? Well, it just so happens that iron 2 plus and iron 3 plus have colors. So we're back in our data book, colors of common aqueous ions. Here they are. So iron 2 is lime green, and iron 3 is orange yellow. So if this reaction, if we could get it to proceed, we were starting with iron 2, it should go from green to yellow. And iron 2 green to iron 3 yellowy orange. So I have a version of this to show you. Here's what it would look like. So here's our iron 2 color. Iron 2 colliding with iron 2, and we get orangey yellow, the color of iron 3. Super exciting. I know. It's crazy. So that would be our diagnostic test for that one. Color changes of ions. Ion colors for diagnostic. You will get some test questions where you are asked to, or you're given a reaction and you're given some lab results. So the lab results, the color changes would help you to identify the ions or the POP test. Okay. Here's another disproportionation reaction. This one's a little trickier. So we have sodium hypochlorite decomposing. That's it, one reactant. Sodium hypochlorite, NaOCl, which would dissociate into Na plus, OCl minus, and water. Those are the only entities present. So we go look at our data table. Okay. Little over there is the flame tests I was looking for earlier. Sodium is yellow. Okay. So Na plus, water, and OCl minus. There's a lot of stuff to look for in here. So we have water. We've already had to switch colors here. So there's our water. Okay. We also have water down here. So it's pretty weak. So it may take part in the reaction, but unlikely. There's Na plus, even weaker than water. So right now all we have is water, but we also have OCl minus. There it is. So that's definitely our strongest oxidizing agent. That's fairly strong. It's like 10 from the top. Now, you are missing a reaction, and the reaction that you're missing, I've given you in your notes. It's this guy. So this is also OCl minus as a reducing agent, and you can write it in your data book. It fits at 0.75. So it fits right here. So if I was going to add this one into my data book, it would sneak in right here. OCl minus, let's add some more color, plus 2 waters. And it's ClO3 minus, 4H plus, and 4 electrons. Okay, so it's sitting right there, OCl minus. So if you add that reaction to your data book, now this kind of makes sense. So here's our OCl minus as our strongest oxidizing agent. Here's our OCl minus as our strongest reducing agent. And this reaction is downhill, it's spontaneous. So OCl minus will react with OCl minus. So we write out those two reactions, and this one we're going to flip so that this is the reactant, not the product. Okay, so I'm going back to my notes. I'm writing out that first reaction. And the second one, I need to flip it. OCl minus is the reactant as the reducing agent, losing 4 electrons. And 4H plus and ClO3 minus. So there's our strongest reducing agent. I'll just get rid of that. And there's our strongest oxidizing agent gaining electrons, and here's our strongest reducing agent losing. Okay, so we've got our two half reactions figured out. Disproportionation, OCl minus is the only chemical reacting in conjunction with water. Okay, we got to balance the electrons. So we have 4 lost, 2 gained. So we got to multiply this one by 2. So that becomes 2 of those, 2 of those, 4 of those, 2 of those, 4 of those. Now we can add them up. 2 plus 1 is 3 OCl minus. 2 waters, 2 more waters is 4 waters. Yes, Casey, I'm going to remember all the waters this time. Okay, we can cancel out 4 electrons gained with 4 lost. 4H plus, 4OH minus, 2 chloride. I just got to clean this up a bit. This should be an arrow. So we're making 4H plus, 4OH minus, 2 chlorides, and a ClO3 minus. Okay, that's a big reaction. Lots going on there. Now, is there anything we can do to simplify this? Anything we could add together? You probably don't see it yet, but you will as we do more of these. H plus and OH minus makes water. H plus and OH minus adds together to make HOH or H2O. So we have 4 H pluses, 4 OH minuses. That's the same as 4 waters. And we have 4 waters on the other side. So 4 waters cancels out with our 4 waters. So the simplified reaction is 3 OCl minus makes 2 chloride and a chlorate. And that is a disproportionation reaction. One chemical acting as both oxidizing agent and reducing agent, gaining and losing electrons to form those products. And that is balanced. 3 oxygen, 2, and 1 is 3 chlorine, 3 chlorine or 3 chlorides. Okay, so that one's tricky. That's about as hard as they get for disproportionation. You can go back to the half reactions to explain who's gaining, who's losing, what's going on in there. And I think we have 1 left. Okay. Last reaction. This one's a little different. We're going to use half reactions to do it. So we have chlorine gas decomposing. Chlorine gas decomposing into chlorate ions and chloride ions. Now, you won't find both of these half reactions in your data book to use 5-step method, but that's okay. We can build our own because it's told us. So we have chlorine gas going into chlorate. Disproportionation, we also have chlorine gas going to chloride. So we have our reactants, we have our products. We can just balance these half reactions, build them ourselves. So a review of half reaction method: 2 chlorines, 2 chlorines, 6 oxygen, 6 oxygen. Okay, 12 hydrogen, 12 hydrogen. Okay, students often mess up the electrons on this one, charges, so let's take a look at it. On the left I have 0, on the right I've got 2 negatives and 12 positive. So that's a total of 10 positive, so I need 10, add them to the more positive side, I need 10 negatives to get to 0. I put those on the wrong side. All of this stuff is on the right. 2 negatives, 12 positives, 10 plus, 10 minus. Okay, there's our first half reaction balanced. Okay, second one, 2 chlorine, put a 2 in front, 2 chloride, 2 minus and 0, so I need 2 minus. Okay, now we got to balance our electrons. Bottom one is times by 5 to get me to 10 electrons. So times by 5, this becomes 10, 5, 10. Now we can add them up. So we have 6 waters, 10 electrons cancel out. 5 and 1 is 6 chlorines to produce 10 chlorides, 2 chlorates, 12 H plus. So 12 hydrogen, 12 hydrogen, 12 chlorine, 10 and 2 is 12 chlorine, 6 oxygen, 6 oxygen. We are good to go. Diagnostic test on this one, if you wanted to verify it, what would be a diagnostic test? This is a good one, H plus. So remember, we knew that OH minus means basic, H plus means acidic. So we could use an acid-base indicator, and it would show us that the pH is low or acidic. You could put some, there's a whole bunch you could choose from. Anything that's going to do a nice color change as it becomes acidic. Bromothymol blue is a good one. So let's just go take a peek at that. There's lots of them here. Slow moving. Okay. Bromothymol blue right here. Bromothymol blue is yellow in an acidic and blue in a basic. So we would start out probably blue or green because the pH would be neutral or probably neutral. So blue, green, and it would switch to yellow. So I could put bromothymol blue turns yellow to show us that it is indeed acidic. Okay, that is it. This is a really good assignment. It's tricky. It's got some challenging questions. So in your study guide, when you work on that one, make sure that you check the answers online. Okay. In my Google Classroom, these are optional. Also do. Let's put optional. This worksheet is lots. I think that's enough for you to do to get a pretty good idea on this. And today I think is going to be Tuesday. So not sure when we're going to assess 5-step method, but it's not for a little while yet. Okay. Hope everybody's doing well. If you have questions or problems, send me an email and invite me to a Google Meet. I've got it on my calendar now. I've got slots open. If you need to have a chat about stuff, I'm more than happy to do that. Okay, take care, everybody.